Okay, this is the Zoom meeting for Math 2460. Friday, October 30th. I think the UNG and maybe Blairsville I heard they're close on the email. Maybe you're close today, but online we can soldier on, and we have a participant. So I don't have your name in front of me because I'm on the camera here, but you tell me who you are.
It's Mark.
Okay. Did you want to see any problems?
I was thinking, could we just go into like the next unit? I don't remember the number.
9.4.
Yeah.
Okay. Yeah, it was a little, I'm sorry, it's not 9.6. It's, yeah, it was a little much to throw at you all in one session with 9.5, but this is going to break your heart, but these are the last two tests of convergence.
Oh no.
I know, it's awful. It's so sad to see this coming to an end, yes. It's called a ratio test and a root test. Okay, they actually are very similar, and you can see the gibberish here. Basically, the logic to it, if you reach back to a limit comparison test, that was in 9.4, your limit comparison test, you needed two series. You were comparing two series. They called them just generically an AN and summation of BN, and the BN here. And the idea was you were supposed to know whether this converged or diverged, and then you did a limit as n goes to infinity of your, well, there wasn't an absolute value back then, AN over the BN. And then depending on whether this converged or diverged, these two behaved the same. But the point was, or the weakness of it is you needed two series. So someone, again, very smart, came along and said, gee, it'd be really nice to take one series and compare it to itself. We want to compare to itself. And could we draw a conclusion about whether it converged or diverged? So you use one series, we'll just use an AN, n equals 1 to infinity. And if you write it out, you get an A1 plus A2 plus A3, blah, 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 blah. And by comparing it to itself, what you're doing is you're going to compare terms. So you're going to take, this is called the ratio test. They use the term ratio test. Take a limit as n goes to infinity. They use an absolute value to ignore any sign switching terms. And you just take a ratio. Basically, the AN plus 1 is the next term over the current term. So it'd be like taking A4 over A3 or so, but you do it generically with n. And when you take this limit, you can draw one of three conclusions. One, if this limit, I'll rewrite it out again, comes up less than 1, you have absolute convergence. Because your next term is smaller than your current term. Always, next term, always less than your current term or smaller. So your terms are getting smaller. Terms getting smaller. All right. If, maybe I won't rewrite the whole thing. If that limit is greater than 1, you have, or infinity, I think the book uses or infinity, you have divergence. See, this being less than 1 means your AN plus 1 has to be less than your AN. All right, and the third one, you know, I've got a less than 1 condition, a greater than 1. What's the obvious third thing? It equals 1. If your limit AN plus 1 over AN equals 1, no conclusion. In other words, your AN plus 1 equals your AN. Your terms seem to be equal and equal. You really can't conclude anything. This is what they're trying to tell you in this gibberish. Your series converges absolutely when your limit works less than 1. It diverges if it's greater than 1 or infinity. And it's inconclusive when it equals 1. That is technical speak for we have no idea what the hell is going on. It tends to lead to a lot of algebra in this, but it works out pretty straightforward if you can follow the algebra. And this is going to come back on us in 9.8, I believe. So this is kind of an important test for the rest of the chapter.
Wait, how would AN plus 1 equal AN though? Like, how does that work?
If the limit came down equal to 1.
Oh, so okay. Okay, that makes sense.
Then you're in your fraction here, this has got to equal this for this to be 1.
Yeah, that makes sense. Okay.
But yeah, it's a pretty straightforward test if you like doing a lot of algebra. Some of them can get pretty long, but it's pretty straightforward series of algebra to work most of these out. Are you ready to charge into one?
Yep.
Okay, I guess we'll just pick it off the homework. So we're at 9.6 homework. We'll, I guess maybe charge into 17. By the way, just to show you how the homework is set up, this first section is ratio test problems. The last test is on the next page. It's root test problems. I'll show you the root test here in a minute. It's similar. And then they give you kind of a sequence of problems here. Use any appropriate test. So they give you kind of a mixture of problems and you decide the test. It's kind of the way the test is constructed. Give you one of these, any random test can come up on the test. So this specific section is ratio test problems. So this is 9.6, 637, 17. Summation n equals 1 to infinity of 1 over 8 to the n. Use ratio test. Okay, I'm going to write the first one out in great detail, and then I think you can see how it shortens up. Usually call this RT for short, ratio test. You want to take a limit as n goes to infinity of AN plus 1 over the AN. They use absolute value again to ignore any sign switching. So we're going to take a limit as n goes to infinity. The bottom AN is whatever's here, 1 over 8 to the n. The n plus 1 means you sub in n plus 1 for that n. Again, absolute value, 1 over 8 to the n plus 1. Questions about that? That's just subbing in n+1 for the n on top and using the current term on bottom. So I'm comparing the next term to the current term. Do we need to pause for station identification?
Nope.
Okay, so we're going to divide these fractions. We take 1 over 8 to the n+1 times 8 to the n over 1. You flip the bottom. All right. On the next step, we're going to look at this, and this happens a lot. How do you handle the base to multiple pieces up here? There's a point of algebra here. People aren't used to seeing it in this form. An 8 to an n+1 can be written as an 8 to the n times an 8 to the 1. Now, some people see that instantly, and some people, they're like, whoosh, what the heck is that? So does this need more explanation?
No.
That's, okay, so pretty obvious?
Yeah.
Okay. So see, when you sub that in, watch what happens. And this happens a lot on a lot of these problems. You wind up doing something similar to this. Okay. So you'll have an 8 to the n times your 1 is 8 to the n, and over on bottom, an 8 to the n times an 8 to the 1. See, by doing this, that allows you to bust your 8 to the n into separate pieces, or bust this into the two separate pieces. And now do you see this and this cancel? And so that gives you a limit as n goes to infinity of the absolute value of 1/8. Well, there's no n to plug in for, so this is just 1/8. And you basically have a case 1. This is less than 1. So my original series, 1 over 8 to the n, converges by the ratio test. You could have seen this with a geometric. This is basically a straight geometric. You could have written this as a sum 1 over 8 raised to the n and used a geometric argument on it. Your r is 1/8 less than 1. It converges by geometric series as well. So I don't know if that went too fast. Any questions about that before we try another one?
Nope.
Okay. Well, the one piece, or the type of formula this really shines with ratio test. Ratio test shines. God, shines with factorials. Shines. Tough morning. Okay. With factorials. It's almost kind of designed for factorials. If you were, do you remember what factorials were? If I had a number, this went 5 times 4 times 3 times 2 times 1, I think you get 120. They did this in 9.1, but it kind of dropped it and ignored it until now. If you do an n factorial, you get n times n minus 1 times n minus 2, back to 1. This ring a bell from 9.1?
Yeah.
Okay, so let's show you how this works. We'll pick one out with factorials, which is basically the next one. Page 637, test sum n equals 1 to infinity. You got an n minus 1 factorial over 4 to the n ratio test. You still want to see all the steps written out, or can we show you the shortened up version?
Shortened one works, I guess.
Okay, let me go back to the first one. I'll show you what we're going to cut out. All right, I probably don't have to show you the formula. I can probably just start by plugging right in. And I probably can cut this out as well. You're basically taking an plus 1 times the flip of an plus 1 here times flip of an. Can we start with that?
Yeah.
Okay. So for a ratio test, you're taking a limit goes to infinity. I'll rewrite it over here. You're taking an plus 1 over an. All right, well, your an plus 1 here, this is going to get a little tricky. You got to really think here. I'm going to put an n plus 1 for that n, and then you're going to have minus 1, close parentheses, factorial, over 4 to the n plus 1. So there is your n plus 1. N plus 1 there, n plus 1 there. Now you see, when I divide by an, I'm dividing by exactly this, which means I'm multiplying by its reciprocal. Is that too fast?
No.
Just cuts out a lot of algebra at the beginning. All right. Can you now see, the limit as n goes to infinity, you're going to wind up with an n factorial because the ones are going to cancel there. I collect the terms. I'm going to divide it by n minus 1 factorial. You want to collect like terms. And can you tell, I'll still keep it, you got a 4 to the n there, and on bottom you're going to have a 4 to the n times a 4 to the 1. Did we lose anybody? I just moved this under this, simplified this, moved this under it, and moved the 4 to the n plus 1 under the 4 to the n, and busted it apart. So you see the 4 to the n's cancel. All right, leaves a 1/4. I could put the 1/4 in front. Don't necessarily have to, keep it inside here. This is why they had you simplify factorials back in 9.1. So I'm going to write out n factorial n times n minus 1 times n minus 2 to 1. On the bottom, I'm going to start with n minus 1, n minus 2, back to 1. And you see I wind up with just n. So I have a 1/4 limit as n goes to infinity of just n. So put in infinity and I wind up with 1/4 times infinity, which is infinity. This is a case 2 ratio test. This means you diverge. So my original minus 1 factorial over 4 to the n diverges the ratio test. Do I need to pause for station identification? I'm not getting any feedback. Oh, I'm up to 6 participants. I've got other people out there I didn't look up. Anybody want to ask anything?
I think this all makes sense.
Okay, in plain English, what's going on? There's a hierarchy of functions. I probably cannot spell hierarchy. Well, that looks right. Hierarchy of functions of, say, strength of functions. All right, from strongest to weakest. Your strongest one is end to the end. And when we say strongest, this means it gets the biggest, gives you the biggest numbers. In other words, you vary both the end, and so you're taking 2 to the second, 3 to the third, 4. You get bigger and big when you increase your base and increase your power. You get the biggest numbers out there. Very close second is factorials. They get very big. When you start with a number multiplied by every whole number back, they get very big. Below that is exponentials. 2 to the n, 3 to the n. E to the n, 3 to the n. Polynomials are below them. That's like n squared, n cubed. And below that, you get weak sisters like logs. So if you look back at this, I think of it like poker. If you know, I don't know if anybody plays Texas Hold'em, I don't know the name of the hand, I never play. But, what a flush trumps a pair, so a factorial trumps an exponential. So basically what happens is these terms are getting bigger and bigger. That's what the ratio test is showing you. These terms get bigger and bigger. A factorial gives you bigger numbers than an exponential, and therefore this diverges. If they started flipped, if they put the 4 to the n over the n minus 1 factorial, this is stronger than this. So the terms would have gone to 0, you would have converged. I don't know if that made any sense at all.
Yeah, that makes sense.
Does anybody want to see any more ratio test problems? If you keep, what that allows you to do is kind of give you an educated guess before you start. See, look at 27. Exponential over a factorial. Factorial trumps exponential. This is going to converge. The factorial will be much stronger on bottom than that exponential on top. These terms will go to 0 and converge. 31, the factorial on bottom trumps that exponential on top. Should converge. 32, they're doing the top two here. The end of the n should trump the n factorial. This should converge. Let's see, 35 will probably diverge. See, 5 to the n is going to trump 2 to the n, etc. Just looking at my crystal ball. 23 will probably diverge because 9 to the n exponential will trump the polynomial on bottom. Right. Is this obvious to everyone, or is it only obvious to me?
No, that makes sense.
Okay. It allows you to make an educated guess at the start. Then if something goes wrong at the end, wait a minute, I thought this should have converted when it died, et cetera. It gives you something to look back at and figure out, wait a minute, did I do something here strange? Anybody want to see any of these other ratio test problems before I flip the page and show you a root test? Root test is kind of strange. It has a very similar conclusion and construction to a ratio test. But anybody want to see one more ratio before I do a root?
I think we can get to root tests.
Okay. I don't know if I'm going to write it all out. A root test is designed for powers of n. Powers, oops, I'm off the screen. Page 634. You have a summation of n equals 1 to infinity of an a(n). Right. And you take a limit as n goes to infinity of the nth root of the a(n). So this will shine when this is raised to an n power. Writing very badly today. Okay, very similar to root. I'm sorry, very similar to ratio. Test. Case 1, if this limit comes up less than 1, you converge. Case 2, greater than 1 or infinity, diverge. Case 3, equals 1, no conclusion. That is the gibberish they are trying to show you here. All right, so maybe I'll give you the first one. Page 638, root test. (39) Summation n equals 1 to infinity n over 2n plus 1. Root test. You take limit n goes to infinity of the nth. I'm sorry, I lost. This is in parentheses raised to the n. My fault. 39. Yeah, that's what really makes it shine with a root test. If it's raised to a power n, some sort of message. I don't know if I can make it go away. Oh no, what did I do? Oh, rats. What did I do? What did I do? I have no. Get rid of all this. Can y'all see all this? I don't know what it's doing.
Yeah, we can see it.
You can see it. Oh no. Let me do this and come back to camera. Okay, are you back on the camera now?
Yeah.
Okay, sure. I don't know what all that was. Okay, so you take an nth root of n over 2n plus 1, and it's raised to the n. All right. So this is why root test shines with powers of n, because you see, when you do the nth root on the nth power, they cancel. And you get a limit as n goes to infinity of n over 2n plus 1. Well, that's an infinity over infinity. You need L'Hopital's rule. So you do a derivative on the top. It's 1. Derivative on the bottom is a 2. You get a 1/2. That's a case 1. It's less than 1. Converges by the root test. I'll just point out, sometimes they mix these problems. Okay. Like look at problem 33. Now they've told you to do this by ratio test. But look at 33. See how you've got an n power on both those pieces? It's much more easily done by the root test because the nth root on this would cancel both those n powers. So yes, this could be done by ratio test if you're a real masochist. And I'd be thrilled to take the 3 pages it would take to write it out if you want to see it. But it's much more easily, with those n powers, it's much more easily done by the root test. Why they stuck it in ratio test section, I have no idea. Does anybody want to see another root test?
Yeah, I'd like to see another.
Okay. Do you want to see 33 done by that? Back on the previous
Sure.
page? Okay.
Yeah.
So 33 by the root test. You have summation n equals 0 to infinity. You've got a 6 to the n. Bottom, you have an n plus 1 to the n. All right, so your root test would take a limit as n goes to infinity of the nth root of 6 to the n over n plus 1 to the n. And you see your n powers, nth root is going to cancel both those powers. Nth root of something to the n, it just cancels. So you get a limit as n goes to infinity of 6 over n plus 1. That'll be 6 over infinity, which is 0. That's less than 1, converges by the root test. Do you want to see the painful steps of algebra to do it by the ratio test?
I think we're good. You don't need that.
Okay. Anybody else out there dying to see that on a early Friday morning? Don't hear anybody clamoring. So the very last stuff for this section is, of course, the very end. And this is what a test on this looks like. Give you a bunch of random ones and use any appropriate test from this chapter. Let me point something out. If you want a very good summary, just flip the page over and they give you a summary of these tests if you can interpret their gibberish. I'll just point out the ones we've done. We've done nth, if you can remember them, nth term was back in 9.2, geometric was in 9.2. I had telescoping on the thing, but nobody ever asked me about a telescoping. We probably won't show you telescoping. We did a piece series, that was 9.4. Alternating series was 9.5. Integral was 9.3. Root and ratio we've just done, 9.6. We skipped direct comparison and we did do limit comparison, 9.4. This is a signal I need to go and retire right now because I have the book and sections of the book completely memorized. I am filling my head with completely useless crap. All right, so I don't know if you find this page helpful. When I've taught this in class, I did give them this page hoping it would help them if you can interpret all this gibberish.
I'm sure it'll help some amount.
Okay. Does anybody want to see anything then from this last section? You can do some of them with multiple tests. So I might be, I might use a geometric and you might use a, another test. That you don't have to do them exactly the same way that I do them. Why is that little square on that? Where did that come from? My son would be able to tell, I'm sorry, my at-home technical advisor. Why am I getting these messages? Okay. Anybody want to pick, why is that square following that thing? Anybody have any clue?
It's trying to scan the QR code.
Is that what's going on?
Yeah, because I think that QR code links to the online book.
Oh, see, this is what drives me nuts. I'm a boomer. If anybody wants to insult me and call me a boomer, feel free. My kids do it all the time. So, this stuff just baffles me that this stuff happens automatically without me telling it to do something. Okay, rant over. Does anybody want to see anything?
No, I think I'm good.
All right, we have 6 total participants. That makes 5 others. Any other of the 5, y'all haven't identified yourself. Anybody want to see any of these?
I don't have any more questions.
Okay. Like I say, you can almost guess them at the start. 63 looks like it's going to convert. See, a cosine there, by the way, is just there to switch signs. It's really not part of the term. I hope you recognize a geometric. The R would be 1/3. It's less than 1, so it should converge. 61, the polynomial up top, it'll be trumped by the exponential, although they're multiplying it by a polynomial, so it's a little fuzzy. 57 is nth term test for divergence. That's what shines on that one. This is a P series, if you can recognize the P coefficient. 5 over n, that's harmonic. Y'all recognize these as quick as I do? Or am I the only one possessed with this incredibly inane skill?
It'll probably take me a little bit longer, but yeah, I kind of understand it.
All right. Well, let's see. It'd be only 37 minutes. Anybody want to go? Anybody dying to see another one, or are you just dying?
I don't know. Here, let's see. I don't know. Trying to pick one from one of the things. 53.
All right, very first one. Okay. Eight, 53, sum 1 to infinity to the n plus 1, and you have 5 over n. I'm separating out the term. Remember, this is the term, the an term. So easiest is to recognize that you have first power on bottom. That makes this harmonic, which diverges. You could also say it's P series with P equal 1. That means it diverges. But I could also do a ratio test on it. See, I wouldn't do a root test because there's no power of n. I could show you a ratio test on it as well. I could regale you. I could also do the integral test on it. I could regale you with 4 or 5, well, I don't know 4 or 5, but at least 1 or 2 other tests that would give you the same conclusion. Anybody want to see any other version of it?
I'm good, but if anybody else wants it.
Anybody else want to see this done by integral test or root test? I'm not root test, ratio test?
No.
No, okay. So yeah, you can use other tests. You don't have to do them exactly the same, way that we do them. On the test, when these are on the test, because we're not having you write them out, because I got no way for you to send that to me, grade it, and send it back. I'll have an argument written out and a conclusion, converge or diverge by, the blank test. And then you will look through it and decide, did I do it correctly? In which case, yes, true, the problem is correct. Or if I, screwed something up in the middle of it, no, the problem is not correct. You'll again grade it true or false, like we've done the other tests. "40 minutes. Does anybody have anything else you want to see? We did this week, we also did the alternating series. Nobody asked about alternating series because we covered that Tuesday, but did anybody have any homework about alternating series? They work through any of these and want to see one?
Yeah, could we see one of those, please?
Yeah, which one? Man, that square is again trying to line up on.
I don't know, whichever would be fine.
Well, 25.
Yeah, that sounds good. Thank you.
Okay. Over n plus 2. All right. They're not asking for conditional, that's further down. They're just asking converge or diverge. So we're just going to run the AST, alternating series test. Which means you check the two conditions. Check your two conditions. And the first one was your limit on your terms, square root of n over n plus 2. Does this equal 0? If it does, it passes the first condition, and then you check the second condition. If it doesn't, you can quit. Rejoice. It fails, it diverges. All right, so you notice that this is infinity over infinity. Square root infinity is infinity over infinity. L'Hopital's rule. So you get a limit, n goes to infinity, top derivative a half, n to the negative a half. Bottom derivative is 1. So you can pull the half out front, and you get a limit as n goes to infinity. Send that down 1 over and n to the half, or square root of n. So you get a 1/2 times 1 over infinity to the half. Sure enough, 1 over infinity, that would be 0. Right, so these terms are going to 0, but that's not that's not enough yet. The AST's got those two conditions. So condition 2, does an plus 1 or is an plus 1 less than or equal to an? Does or is, I guess, better English. All right, so again, this kind of presages the ratio test. An plus 1 into this gives you square root of n plus 1 over n plus 1 plus 2. Is that less than or equal to square root of n over n plus 2? Okay, something like this. You see on bottom here, you're getting a square root of n plus 1 over n plus 3 less than or equal to a square root of n over n plus 2. Okay, this gets fuzzy with your n's in both spots. Yeah, this is larger than this, but then this is larger than that. Yeah, I usually resort to a calculator, and you really want large n. So I might use 1,000. just pick something to test. Square root of 1,000, add 1 over 1,000, add 3, and just see if it's less than the square root of 1,000 over 1,000, add 2. Otherwise, there really just isn't any much other way to check it out. So this is 1,001 there. So really on the left, I'm getting a square root of 1,001, and I'm dividing that by 1,003. See that? Square root of 1,001 over 1,003, 0.03154. And let's compare that to square root of 1,000. Oops, come on, back up. 1,000 divided by 1,002. 0.03155 versus 0.03154. You see how close they are? 5. So yes, in that play, they match to the 5 there, and then the 4 is left. I'm going to take that as evidence enough that this passes, yes. So it converges by AST. Questions about that?
No, I get it. Thank you.
Yeah, if the ends are not on top, it's a much easier check. But when they do the darn ends on both top and bottom, it's a little tougher. All right, the very last stuff was the absolute convergence, conditional convergence, or finally divergence. We showed you a big flow chart on Tuesday. Anybody want to see one of those?
Yeah, sure.
You want to pick one out?
I don't have any like thing in front of me at the moment, so.
Okay, well, here's kind of, I did the first one on the other page. They give you factorials on some of these. I wouldn't do the ones with factorial. I should have left them off the homework. That's really, it's can't really do you don't really do a factorial unless you have a ratio test. So why they put this here when they haven't shown you ratio test, I have no idea. So I'm really kind of ignoring 53 as well.
What about, I don't know, let's do 57.
All right. $630. Sum n equals 1 to infinity of cosine n pi over 3 over n squared. Your 3 choices: absolute convergence, conditional convergence, divergence. All right, this technically is not a pure sign switching. If n is 1, you're at cosine of pi over 3, which you're at a half. If n is 2, you're at cosine of 2. It's putting a number like a half, negative half, not just 1 and negative 1 on it. But it is switching signs, and that a half doesn't affect anything. So I'm still going to regard it as sign switching, even though technically it isn't. So my term really is 1 over n squared. My an here really is still 1 over n squared. So I'm going to test sum of 1 over n squared. Again, ignore this as sign switching, even though it technically isn't quite. And do you see that this converges? It's P series. P equals 2 is greater than 1. So you see, it's going to converge no matter what this is doing. So I don't have to test alternating series or anything. See, if this had diverged, I would check alternating series and see if that converged or not. I don't have to check it. This converges basically with all the signs positive. because it's P series with P greater than 1. This is absolute convergence. This one does not get deep into the flow chart.
Okay, and then we just stop there. And then if it would diverge, then we have to do the other test.
The AST, yes.
Okay.
So in other words, okay, if it diverged, I mean, all the signs positive, so it got too big to converge. So then with the AST, you're assuming every other sign is negative. So you check those two conditions on that AST. If that converges, then it's conditional convergence. If AST converges, then you have conditional convergence. And if the AST still didn't work, then it finally diverges.
Okay.
Yeah, it diverged up here, then it diverged with the AST, so it finally diverges. I could rewrite the flow chart if you want to see it.
No, I have it in my notes somewhere. I should be good.
Yeah. Anybody want to see anything else?
I think I'm good.
Okay, I think it's quiz 9 then. I think I sent out got quiz 9 ready last night. Quiz 9 then, it's due Sunday. By Sunday, we're into 11. We're in the last month of the semester, people. Unless you want to be hyper technical and count the first week of December as finals, but
Don't we have like 3 weeks? Don't we have 3 weeks left and then Thanksgiving break and then the finals after?
It's about right. Maybe 4 weeks technically if you, well, no, last week is Thanksgiving. Although they're making us come Monday and Tuesday of Thanksgiving week.
Wait, are they?
Yeah, they are. I remember that.
Oh, I didn't know that. Oh, okay.
I believe so. I believe the semester ends the 24th, I think which is, I believe, Tuesday of Thanksgiving week. I mean, I have that date quite, I may be off a number or something, but yeah, because they're ending early, they're making us come Monday and Tuesday of Thanksgiving week. Of course, that just means I'll be holding the Zoom sessions that Monday and Tuesday.
Yeah, which isn't that bad, I don't think.
Right.
Like we're getting like a 2 weeks off early, so like 2 days in Thanksgiving break is me.
Yeah, that's the way life was for my entire career from 1980 when I started in the university system at Tech all the way to 1998. They made us come Monday and Tuesday. Then when they converted to semesters, no, actually when we merged with North Georgia College, turns out North Georgia College had been taking the entire week the entire time, and that's when we finally got the entire week. But again, y'all don't care about that. That's politics of the system. Now we're back to quarters, having to come half of Thanksgiving week. Great. Okay, I'm sorry, rant is over. Anybody want to say anything else? I'm wasting your Zoom time with my boomer rants.
I think we're all good. Thank you very much.
Absolutely.
Yeah.
Anybody else want to say anything? Please speak up. Otherwise, we'll go ahead and end the meeting. Thank you all for coming out early on a Friday morning. And so, yes, we'll go ahead and end the meeting.
Thank you.
Thank you.
Uh-huh.